So far in this chapter then, we've talked about how the Java Virtual Machine runs our code. But what can we actually do with this knowledge? What are the opportunities to improve performance when we know this? Well, when code has been compiled to Tier 4 or using the C2 compiler, we also know that if it's going to be used a lot, then Java will place that code into the code cache. But this code cache has a limited size, and if there are a lot of methods that could be compiled to this level, well then some will need to be removed from the code cache to make space for the next one to be inserted. And the removed method could be recompiled and re-added later on. In other words, in large applications with lots of methods that could be compiled to level 4, over time, some methods might be moved into the code cache, then moved out, then moved back again, and so on. Now, when this happens, the default code cache size might not be sufficient, and increasing the size of the code cache can lead to an improvement in our application's performance. Now, if that happens, you might see the following warning message appear in the console of your application. The warning message is code cache is full, compiler has been disabled. This is telling us that the code would run better if another part of it could be compiled to native machine code, but there's no room for it in the code cache. What's more, all the code that is in the code cache is actively being used, so there's no part of the code cache that can easily be cleaned up. This is a warning message. It doesn't stop your application running, but it does mean that it's not running in an optimal way. Now we can find out about the size of the code cache by using a JVM flag, which is -xx : plus print code cache. Let's run that with our example to see what that looks like. So it would be Java -xx : plus print code cache. And then we're running the main class. Let's put in 5,000 prime numbers again. And what we're told here, it's the top line that's most interesting. Our code cache is about 20 megabytes, and actually only about 1 megabyte was actually used. So there's definitely nothing to worry about in our simple application. But clearly in a more complex application, if you see the size that has been used getting close to the size of the code cache, then a tweak to the code cache size might well be helpful. The maximum size of the code cache is dependent on which version of Java you are using. If you were using Java 7 or below, then it was either 32 or 48 megabytes. It was 48 megabytes if you're using the 64-bit JVM and 32 megabytes if you're using the 32-bit JVM. If you're using Java 8 or above and you're using the 64-bit JVM, then the code cache can be up to 240 megabytes. So we can change the code cache size with 3 different flags. Initial code cache size is the size of the code cache when the application starts. This is normally quite small. The default size varies based on your computer's available memory, but it's often around about 160 kilobytes. Reserved code cache size is the maximum size of the code cache. In other words, the code cache can grow over time up to the size of the reserved code cache. So using the initial code cache size and the reserved code cache size, we can say how much we want it to be initially and how much it could grow up to if needed. The third parameter, code cache expansion size, dictates how quickly the code cache should grow. As it gets full, how much extra space should we add each time we grow the code cache? Now, each of these values can be provided in either bytes, kilobytes, or megabytes, and we'll see how to provide them by setting one of them. I think we'll change our application to say, let's make the reserved code cache size 28 megabytes rather than the current 20 megabytes. So to do that, what we'll do is say, run our application Java. I want to set the reserved code cache size, and actually these flags have a slightly different format. It's -xx:, but we don't have a plus or a minus because we're not switching a flag on or off, we're setting a value. So we have the flag name, in our case that will be reserved code cache size. and then we set that equal to a number. If we want to specify the number in bytes, we just put a number in here. If we want to say it's in kilobytes, we follow that with a K. If we want to say megabytes, we follow it with an M. And the K or the M can be in lowercase or uppercase. Now in this example, the maximum we can provide is megabytes, but if we were using a flag here where you could provide something in gigabytes, well, you'd put a G there instead. But I want to use 28 megabytes for this example. To check its work, we'll also use the print code cache flag. So that will be plus print code cache. And then the rest of our command line to run the application, so it's the main class, and we want 5,000 prime numbers. So let's run that and see what the output looks like. And well, you can see here now this time the code cache size was 28 megabytes rather than our previous, actually I think that would have been then about 24. So we've managed to tune the size of the code cache. So if that's something that is concerning you, the code cache size, we now know how to tweak it at runtime when our application runs.